Okay, areas. Not quite.
Can we still sing, Mr. Harry?
Alright, I'm just going to give you a few formulas which I'm sure you're familiar with. Let's look at the square. Let me draw it over here. It's a bit nicer.
Oh, see those?
Yeah, you know, we could just, yeah, why don't we
It's
just
gonna be
do that?
orange. True.
This one right here?
Right, it's gonna be orange. Oh, no.
What's wrong with
No. See, like you can change the colors.
To the left,
to the left, to the left.
Everything
I need my pen. Is this my pen here? Yeah, that's
In
it.
the closet. That's not, yes, in.
Like that?
Yeah.
Alright, let's go ahead and get a formula for this. Square. See the pen sometimes. Anyway, here comes a square. Got four sides the same. And also, of course, the four angles are right angles. Not wrong angles, they're right,
They're not left.
What is
not
that?
left. Who's that, Maddie? Okay. Alright, but the formula is pretty easy for this in terms of the area. The side is S, they're all S all around. So the area, instead of saying length times width, we just say side times side. And that area would be just simply side squared. So for example, we've got a square whose side length is, let's say 8 inches. And the area would simply be A equals, yes, 8 squared, which is 64, and that's going to be in inches times inches squared. Alright, let's take a look at the rectangle now. I'm sure I can get it from here again.
Yeah, there's, see, go up, right there, go up.
Or we can take it from here. Alright, let's take it from here.
Oh, look at that.
Yes.
Oh, yeah.
Oh, yes.
That good?
Yeah.
Snazzy.
Nice little
Alright.
rectangle we got there.
Alright, so we got a rectangle whose length is, let's say, L,
Ooh, that's a nice one.
and the width is W. So we have the area. Luke, do you remember the area of a rectangle?
Length times width.
It's going to be length times width. Alright, so, for example, if we had a length of, say, 10 meters and a width of, say, 5 meters,
Wait, what line
What
did
does
you
that
draw?
say? 1
10 meters. So the area would be 10 times 5, and that would be 50 what, Jessica? What would be the units? Give her a chance. What will be the units? Meters times meters. Meters times meters. M squared. Meters squared, like X times X. Meters squared. Alright.
50 was leading me in the wrong direction.
Let's go on to a triangle. I don't think we have any triangles on here, do we?
Yes,
Yeah.
you did. Go
Yeah,
down,
you
right there.
got it.
Got it. Triangle. Oh, 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 got it.
Alright. Good.
Oh, come here.
Well, we got a lot of emotion in here.
We had very happy. We're the end of the year. We're just so excited for math, Mr. Henry.
Alright, I need something. The base is down here. The base is the bottom here. And then let me give it a height here. We need a height. Let me get a nice height.
Oh.
Let's get it
Ooh,
nice.
it's the lightning bolt.
Let's draw a nice height coming
There's a
down like
lightning
this.
Yeah, look up. Looks like a lightning bolt. Look up.
Harry Potter.
Shut up.
Alright.
No one likes you.
So that would be my height. And you want to make sure the height is perpendicularly measured above the base. So the area of a triangle, Tiffany, pay attention. No, do you remember the formula for the area of a triangle?
Base.
Base times height divided by 2.
Yes, it's base times height divided by 2. Sometimes you might see it this way. Half base times height is the same thing. So if we have a height of, let me just make some numbers up. Let's say the height is 11 centimeters, and the base is 4. All right, take 4. Then the area would work out to be 11 times 4 over 2. Yes, we can knock this down by 2. And this would be 22 area. Now what would be my units? If I have centimeters here, times centimeters, that would be what? Centimeters square. Alright? So that would take care of the square, the rectangle, and the triangle. And let's just do one more. Since we just studied the parallelogram, let's go ahead and let me see if I can put that somewhere.
I don't think there's gonna be a parallel.
Oh, here's one. Is this one? That's square?
There's a down button. I can't take it.
Oh, that's
Yeah,
true. There
we
is a
got
down
some
button.
more here.
Oh, there's smiley faces.
Press it again, press it again.
Let's go
Press it
smile.
again.
Oh,
Press it again.
one more time. One more time.
Yay!
I swear I saw one, man. Oh, there's one.
Where?
No.
There's a smiley
Alright,
face.
look.
Just go ahead and click it, and now
Here,
right
watch.
there, where your mouse is.
No.
Oh.
Yeah, I saw it. I saw it. I saw it. I saw it.
Oh,
It's gonna be funny because none of this is on the actual recording.
Yeah, that's fine. That's fine.
Oh.
No, the red line covers the.
Not yet.
Oh.
Oh, pickles. Oh, come here. Oh.
Whenever I try to get across there. Let me see.
Can we just start singing?
You're
Yeah,
moving
ready?
forward.
Yeah, we'll sing.
Oh.
Let me see if I can get it from here. Where's that down?
You gotta pull it up a little bit.
This way. Wait, till we're done with this.
Hey, there you go. It's got recorded.
I'm not getting it. All right. Let me just draw one real
Everyone's
quick.
gonna hear you just say.
Okay, let's go ahead and draw.
Oh man.
Oh, yeah.
Oh.
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 Yeah.
Yeah, go ahead and draw a parallelogram and let me give you the formula.
Oh.
Oh. Wow. That's probably better than what you were gonna get.
Probably. Here comes the base,
Oh,
and the height is gonna be the perpendicular distance above the base. Let me get it. That's a bit nicer than freehand here. Let me just take it vertical all the way down.
Whoa. Whoa.
All right. So this has got to be, the height has got to be perpendicularly measured above the base like this. And the area, this is a parallelogram I should say. This one might not be so familiar. It's going to be just the base times the height. You said, well, that's just like length times width. I know. It's just pretty. Yeah. Well, you know what? If I were to take this, let's say if I take this shaded triangle over here, and I cut it off, and I move it over here, and drop it down here,
It'd still be a
it would be
parallel.
what? It'd be like a rectangle, wouldn't it?
No.
See it?
You know there's a dotted line, Mr.
Yeah.
Henry. You don't have to.
Well, I could actually take this triangle, put it over here, and that's why it's the same as base times height. Okay, so if you see a parallelogram whose base is, let's say, 7, let's say it's a big one, 7 feet, and the height is 12 feet,
It'd be really big.
so it'd be a big one, so the area would be what? 7 times 12, and that would be what, Priscilla?
It would be.
You need to be paying attention. 84, Austin, what would be the units? It's going to be feet times feet. Get that? It's like x times x, feet squared. Luke, you're not taking any notes?
Yeah, I am. I have notes going down here.
All right, so that's pretty much it in terms of basic areas. When I do circles, then I'll give you some area for circle and so on, all right? So
Pie.
let's go back. Yeah, we're gonna get into some pie, maybe apple pie and cherry and key
We're
lime
having
and so
pie?
on.
Wait, we're having pie? We're having another party?
Yeah, we're gonna have a little time together. That's why
When?
we're gonna have to just plan that.
Oh yay! We get to do
I don't know if we're gonna eat, but we're gonna have a little time together.
What are we eating?
All right, let's make a transition right now. I'd like you to go ahead and draw a circle
Oh.
as best as you can. Let me give you some time to draw a circle. I'm going to study some basics for circles. Okay, Priscilla, go ahead and draw a circle.
name of circle. Can we name it like
Yeah, we're gonna go ahead and put R as the center of the circle like I've got.
Can mine be taken?
Can we see who can draw?
And then draw this segment from point F to point C, kind of horizontally across like that. And then give me a vertical segment down from all the way up towards where Jesus is, all the way down.
Or say we draw all of that.
Okay, not so close, Tiffany. All right,
What?
and then give me a line over here. Make sure you put the arrows on it like this.
Wow, that was a beautiful circle.
Is it? Maybe we could project it.
Ooh,
All right, then give me a point here, A, point E. And just go ahead and draw this as best as you can. Let me give you a couple minutes to get that. And then we'll name some basics concerning diameters and chords and all
Label
those
them the
things.
same.
Yeah,
That's a pretty good circle.
yeah. Let's wait.
Yeah.
Okay, set all that.
What? On the side of the right. I did circle.
Far from my zone.
Oh, it's not in the middle.
All right, Daniela, you got it?
Yeah.
Okay, because I'm going to start giving you some names, giving you some
Wait, what are we doing? Are we
definitions.
like what, drawing on a circle?
Just draw this basic figure, what you see right here.
Oh, so you want us to draw like the A,
Yeah,
B,
just
S?
draw this line right here.
Okay.
It's got a special name.
You got it.
Is this all of me? Do you have to draw all this stuff on the
Yeah, draw this line here. Draw this radius here, RD, another one, RG, and we'll talk about them.
My triangle looks so small.
You're trying.
What about a circle? Whatever it's called.
But I didn't realize that the circle would put such musical tones in your bones.
What?
Oh,
that
Put tones in your bones. It rhymes so
It's a
funny.
rapper.
You
Well,
should
that's
be
after
like
she's
the
been
new
singing.
poet. You're a poet.
All right, Bridget, you got it? All right,
I can't draw the
Josh, you got it?
Yes. I don't have it yet.
All right, I'm going to show you how to name a circle, and then remind you of some things which I'm sure you've met before, like radii or radiuses and so on.
Jerry.
All right, here we go. How do we name it? The circle is named according to the center, so you'll see it like this in your book. Yes, circle with a little dot there, then capital R. If the center were P, then the P would be here. If the center were C, then C would be here. That's the way you name a circle. Circle R.
But you
All
put
right.
it under diameter.
Name of
Yeah.
diameter.
You put it
Okay.
under diameter instead of circle.
I did it in the wrong place. Let me go back.
Yes.
Sorry.
It's okay.
Let me just take it.
And everyone has to say.
Oops.
Oh.
No, what happened?
Oh, it's
Oh no.
No,
It's gone.
you can do the redo button and you can go back and then back and then back. Here, watch.
We go back with.
No, not that one. The redo button at the bottom.
Which one is
Yes. No.
here?
There. Other one. No, that's the no. That
Am
one.
I losing?
Other one. Other one.
Reset
We sound like animals.
Yeah.
Whoa.
Oh.
I hope I didn't.
Oh.
All right.
Yay.
Circle,
Oh, praise the Lord.
Oh.
circle R. All right. Let's go to the diameter now. I think I've got at least one here. Let me see what how much you remember. Noah, can you name me a diameter?
The diameter would be FC.
It's going to be FC, goes through the center. So it's a segment, so it's F. Let me do it properly. C with a little bar line over here. Is there another one?
HG.
HG would be another one. Let me see if I can get that right there. HG is a diameter as well.
What?
AB, is AB a diameter?
No.
No, but it's got
It's
a
already
name, and I'm going to get to that pretty soon. All right. Alex, can you remember what a radius would be here?
Yeah, it would be RC or F.
RC would be a radius. All right, let me write that down. RC.
FC. Wait, FR.
Did you say, what else did you say?
Or FR.
FR would definitely be a radius.
Or GR.
Got quite a few of them. What else? Anybody said RD?
GR, HR.
Or
Wow.
DR.
GR. So we've got a lot of them. So you can put a few more in if you like. RD. But that you got the idea. And the radii are always equal to each other. Always. So when we get to some actual problems involving that, you know, if you know one radius, you're going to know them all for the same circle. A chord. Let me see if anybody know what a chord is. It's not musical.
It's three letters.
Yeah, you.
It's FRC. Is that a chord?
Josh, you remember what a chord is, or do you know? Yeah, chord is a segment that starts on the circle and it goes to another point on the circle like
So
this.
FRC
AB.
is right.
So
That's
AB, it's going to be two letters. AB would be one.
Oh.
Can you see another one, Grant? Another chord?
You're so confident in your
Have the geography too.
FC.
FC, diameter, all diameters are chords, but it's just a special chord. It goes through the center. Alright? You could actually make AE one if you're going to cut off this part of the line here and
So
cut this one
basically
off.
all of them are chords except for RD and like RH,
And this-
RF.
let me give this line.
RDB radius.
Yeah, give this line the letter T. And name this line the letter T because you can name it with a lowercase t like that. Tiffany, pay attention and keep your focus here. You know what I mean. Pay attention all the way. All right. So now, secant. A secant is a line that intersects a circle twice and it keeps going.
AE.
Okay, so AE definitely will be a secant line. And I think I've only got one here. AE. And make sure you put your double-headed arrow on this one because it keeps going. And it intersects not only at point E but also at point A. That will be a secant line, and that's the only one we've got here. This line right here, line T, is not a secant line.
It doesn't go in.
It's going to be a tangent line. All right, a tangent touches at one point, and that's it. And this point here has got a special name. I'll just give you the name which I don't have here. This point D is called the point of tangency. Point of tangency.
Why is there a T?
Because you can name a line by a lowercase letter as well.
I know, but it's D, not T.
T is the name for this one. All right, D is the point of tangency. All right, now let me show you something here. Wherever a tangent meets a radius, we always have a right angle. Always right here. So this tangent line T meeting radius RD here always have a right angle. So you can make a note of that. When a tangent intersects, Noah, pay attention. We have a right angle. Luke, write it down.
Okay.
Again, whenever a tangent meets a radius, we always have a right angle, and we're going to be doing some questions concerning that very thing. All right, let's go ahead and go forward here. Let's see what else I got. All right, what is it? All right, you absolutely have to go quickly and be right back because I'm going to be teaching still. All right, you got common tangents. You got two circles here. Let me show you how many common tangents we can draw. We can draw, we can draw a number of common tangents. Let's demonstrate it like this. I can draw one. Common just means it's going to touch both circles. Touches that one and it touches that one as well. That's one. We can draw another one here. Just touches the bigger and then the smaller. Like that. Okay. Can you see another one I could draw which is common to both?
Oh, you go right to the
In
middle.
the middle.
Yeah, right in the middle. I could come
Oh, you
right.
can't do that with that one though because. Oh, never mind.
So we can have three common tangents. I think that's pretty much a maximum we can have when we're dealing with circles. How about these two circles? How many common tangents do you think I could draw?
2.
Yes, it's going to be two. One here. Oh, it's not quite.
Whoa.
It's not a tangent.
I don't think that's
I don't know.
So
Alright.
today is too fast.
Yeah, you're gonna have to press that like.
Let me try that again. why wiggled like that? Let me try again. Let's see.
There it goes again.
Not a little bit better, but not perfect.
They're gonna touch.
Right here, and then we can get a second one here. So we got two. So here we got three of them here.
But number 3, you couldn't do anything.
We've got two. How about here? Can we get any comment tangent? None. Zero.
0.
None. All right. I think I got some. Let me show you one more thing before.
Okay.
All right. That's so much for common tangent. Let me give you an example now. And I think
Oh, this is where we all fail.
no, you're not going to fail. These are just right triangles. You got a tangent here intersecting a radius, and if you ask to find x, you can find it because you know what? What theorem?
The right one.
A
A squared plus B squared equals C squared.
Absolutely. Yes, you can find x because c squared is still equal to a squared plus b squared for every right triangle. All right? So what would be my c? The 100 and the 96 are the x.
100.
100. So we got 100 squared. Going to be equal to my, let's say, x squared plus 96 squared. I'm going to need some help with a calculator to work this out. Well, 100 squared is going to be easy because it's just 1 and then 4 zeros. 1, 2, 3, 4 zeros. All right, 10,000.
That's
But
fine.
96 squared, I do not know off the bat. Okay, look to the other seat. I'd like you to be focused here. 96 squared. Somebody do it on the calculator for me, please. 96 squared. I'm waiting.
96.
Tiffany, you're distracting the neighborhood.
9,216.
9,200 what?
16.
16. Confirmation on that? Joe, you got it?
Oh.
All right, so we subtract this from both sides. 9,216. All right, that's gone. So we're going to get x squared is equal to, okay, go ahead again, Joey. 1,000 take away that, looks like, what is it? Josh, you got it? I mean, Roger, you got it? 784? 784, confirm there, 784. I need a square root on this. X, what is it? 78? 28, exact. All right, confirm. Square root of 784.
28.
28, all right. So that's pretty much it. This one is a little bit more awkward. Let me go ahead and show you how this is done. Because you got the radius here of x, the radius here of x, but beyond the radius, we have this segment of 32. So,
No, that's not awkward. We can find that.
well, we're going to use the same formula, but let me see if someone could help to set this up. Josh D, how would we set this up?
Oh, I got this.
Huh?
I got this one.
Are you thinking of it, Grant? Go ahead.
You can do x plus 32 squared.
X plus 32. Yes, that's
All
all
squared- all
squared.
squared, I meant.
Uh-huh. Equals?
Plus, well, I meant like.
That's
Oh
that.
no,
that's
that's
that
it. Yeah, that's plus or equals 56 squared plus x
You
squared.
got it. 56 squared plus
Yeah.
x squared. All right, any of you remember how to FOIL this kind of thing?
I do.
From algebra 1, x plus 32 times x plus 32? Yes?
Yes.
Yes, it's going to be x times x would be x squared. And then what?
X
X
that's
times
32x.
32x. All right, let's work it out. And then 32 times x would be another 32x.
So
And
that's
finally, 32 times 32.
96x.
1,000.
96x.
32 times 32.
1,024.
96x.
1,024.
1,024. 1, 1024. Okay, just hang on a minute, let me finish this. 56 squared. 56 squared. David, what would that be? 56 squared. You got a calculator.
3,136.
3,136, thank you. And that's plus x squared. Here's a nice way to do this. Since you've got x squared on the left, namely this, you got x squared on the right, you can actually subtract x squared from both sides. That way you can solve it easier. So that would be gone from the left side, that would be gone from the right side, and we have to put these together. This becomes 64x plus 1024 equals 3136. We're going to subtract the 1024 from both sides. Okay, Jessica, go ahead for me, please. 64x would be equal to let me see, I see a 2, I see a 1, I see a 1, I see a 2. Alright, divide by 64, and I get x is equal to, everybody got that? 2112 divided by 64. Is it? 33, like that, okay. 33. Alright, so the trick here is just to realize that this hypotenuse got two parts with x plus 32, and that has to be all squared, and then a little bit of foiling here. I'm going to give you a worksheet. I'd like you to work on that worksheet for your homework. I'll give you a certain one, so there's going to be a worksheet